This video is about Leontief's input-output model, which is a very good application of systems of linear equations. This Leontief's model is an effective matrix algebra in problems concerning economic system. Leontief created this model during the year 1941, and he was also awarded the Nobel Prize for his work in economics in 1973. It is a model for the whole country or a region. In this model, there are n industries producing n different products such that the input equals to the output, or the consumption is equal to the production. That is, this model shows that the production equals consumption when there are n industries, each producing n different products. The input-output matrix is explained this way. Assume that the economic system has got n different industries, say I1, I2, I3, etc., In, each of which has input needs such as raw materials, utilities, etc., and the outputs are like finished products. And let Dij be the amount of output of the jth industry needs from the ith industry to produce 1 unit of output per year. And each Dij is less than or equal to 1, because this Dij, if you are taking that as a probability, then it should lie between 0 and 1. The sum of these entries must be equal to 1 or less than or equal to 1. Now, the input-output matrix can be represented by D, where Dij is the amount of output of the jth industry needs from the ith industry to produce 1 unit of output per year. In order to understand this model, let us consider this example where we are considering a system consisting of 3 industries: electricity, water, and coal. Production of 1 unit of electricity requires 0.5 units of itself, 0.25 units of water, and 0.25 units of coal. Production of 1 unit of water requires 0.1 units of electricity, 0.6 units of itself, and 0 units of coal. Production of 1 unit of coal requires 0.2 units of electricity, 0.15 units of water, and 0.5 units of itself. We are trying to find the input-output matrix for this system. We know that electricity requires 0.5 units of itself, so that becomes the first row, first column element. And electricity requires 0.25 units of water here, so that will be the second element here, second row, first column element. And it requires 0.25 units of coal, so that is this. So the same way we can fill the remaining of this matrices. So the matrix what we find here is the input-output matrix for this system. Let us consider the matrix form for this Leontief's input-output model. First, let us take the closed system. For a closed system, if we are trying to find the total output for the ith industries, that will be Xi, and which is Di1 X1 plus Di2 X2 plus etc. Din Xn. Suppose if it is an open system, then that Xi will have the same as the closed system plus Ei, where Ei represents the external demand for the ith industry's product. So the system of n linear equations X1 will be D11 X1 plus D12 X2 plus etc. D1n Xn plus E1 etc. Xn will be Dn1 X1 plus Dn2 X2 etc. Dnn Xn plus En. So we can rewrite this matrix in the open system as, say, some X equal to the input-output matrix D times X plus E, where E is the demand, external demand. So X is the output matrix, E is the external demand matrix. So in this case, when we take this equation, matrix equation, X equal to dx plus E, this X is nothing but I times X, because I is the unit matrix. So X is like 1x, we have Ix. So if we are trying to solve for X, Ix minus dx is E, or X times I minus D is E. So you can easily get the value for X by taking the inverse for 1 I minus D. So your X is going to be, your X is the inverse of I minus D. If I take I minus D, the inverse, and if I multiply by E, that will be the value for X. So if we take this Leontief's input-output model, in order to solve a matrix, we know that we take X equal to dx plus E, or I minus D times X equal to E. Let us try to make use of this in this example. So an economic system composed of three industries has input-output matrix, which is given below. So D, the first column has got some probabilities, B has got some probability values, C also has got some probability values. So it gives the supplier use model or input-output model. And the external demand is also given as a matrix, 20,000, 30,000 and 25,000. So if you are trying to find the solution for this, first of all, we must take what is I minus D. I is a unit matrix and D is already given. So when I'm taking unit matrix I, we know that it is, since it is a 3 by 3 matrix, it must be 1, 0, 0, 0, 1, 0, 0, 0, 1. So I minus D is this, and I minus D whole inverse will be this result. You can make use of your TI-83 and get the result easily. So X will be the inverse of this I minus D multiplied by the external demand matrix E, and hence you get the value for A, B, C as 46,750, the 50,950 and 37,800. The solution of the output matrix X is given as 46,750, 50,950, 37,800. That means the output for industry A is 46,750 units. The output for industry B is 50,950 units. And the output for industry C is 37,800 units. Let's say this example. An economy has two industries R and S. The current consumption is given in the table. So in this, the external consumption, current consumption is 20 and 100. But if you're assuming that the new external demand is 100 for R and 100 for S, you are asked to find the new production level. So here X is, already we have 20, another 100, so it will be 120. And for S it is 100 already, but the new demand is also another 100. So the total will be 200. So we have got X as 120 and 200. So when we are trying to find the first matrix for the probability, it is 50 out of 120, 50 out of 200, and 60 out of 150, and 40 out of 200. And the new demand is 100 and 100. So if you are trying to solve X dash equal to I2 minus D, D is A here, whole inverse, and the new demand is B dash, that E is B dash here. So when you solve this equation, you get 307.3 to be the new production level for R, and 317 to be the new production for the industry S. So this video helped us to understand what is Leontief's input-output model using the systems of linear equation and matrix algebra. Hope you enjoyed watching this video. Thank you for listening and thank you for your patience.